Cool. So today I want to look at the Ethereum node package. And in particular, when we were looking at the database stuff yesterday and going through the Geth command itself, there is an entry point that first of all creates a config file stack or something, and then it runs a node with that information. So source GitHub Ethereum Go-Ethereum. And yeah, in particular, if we look at command Geth and in main, so this is the main like the very first here actually. It's pretty much the very first thing that gets called by Geth. The main entry point. And you can kind of see this. They use this CLI framework here, which I've played with a bit. And what they essentially do is you call that CLI framework, and it builds all the so you can, when you're doing Geth, you can go Geth account dash mine or something like that, whatever, and you can have these as like, so this is your main command, these are your sub commands, these are your flags, and it just gives you a method for naming and building these in structures rather than sort of saying if dash mine do this. So they got these metrics flags, metric enable, whisper flags. All this stuff is defined as this CLI flag. So it'd be these because that's what the flag is. And there's heaps of them. You can see exactly where it's going. And they all do separate things, and there's all functions called as a result of them. But this app action Geth, that defines this Geth command, and the thing that happens when you call it is this Geth function, which when we go down here, the main entry point, and it gives you this context so you have access to all the flags and stuff. So what it does is you have, if your arguments, which is this context arguments, is greater than 0, it gives you this invalid command with the actual argument itself. So if you go Geth something, it gives you invalid command something. Anyway, so what it does is it does this make full node, which I want to look at, and it does this start node. So slash make full node. Where are we going to find that, do you reckon? Command less, see Geth. In the config, just make full node. So it make config node, and register the service. So this make full node is returning this node object, and that's kind of what I want to get looking at today. I mean, a node is just a server or something, like a program, I guess, even more generally, that's running on the peer-to-peer network. I don't exactly know what this node does at this point. I guess it just gives you the like start listing, stop listing functions, and it allows the program to be sent and receive messages. So this is all Whisper stuff. This is all Whisper. So that's not important to us right now. The stats daemon's probably not that important to us either. It's keeping track of the stacks. If the dashboard flag is enabled, that's come up a couple times actually. Geth dashboard. Puppeth must. Ethereum. It's not what I thought it was. Anyway, cool. So first of all is this make config node. You take a context, it gives you a node and a config. It loads the default configs. If not, it loads the file. Set node config. And calls Node.new. Then utils.set node config. So it goes through the context and puts all the flags on this config. So it starts with the defaults. If you've got a config file specified, it'll load them. After that, it'll go through the flags that you've put into your Geth command line. So Geth-s password or something, and puts it into this config. And then it goes Node.new with the config. And yeah. Set eth config. If global is set, Ethereum stats, do something. Show dashboard, show Whisper stuff. So this is where it's calling that new config, new node. Anyway, and then after it's called make full node, so it's got the actual node, it says start the node, which is here. Utils start node with the stack. Which is the node here, they call node here, pass it as here, which becomes stack here. So they call start node on stack, just start the node itself. I'm not sure what that means at this point. Here it goes through some passwords, because you've got to unlock accounts to use them on the command line. if they got passwords and stuff. Create a chain state reader. See, this I don't understand yet. Cool. But I guess here is this Node.new with the config file, which is just a bunch of defaults. So if I have a look into this node package, node. Yeah, this is what I want to look at. But what else is in there? Let's get a quick look. Vim API 400. So that's a significant one. Vim config dot also significant. Vim defaults. Ooh, default data directory. The Windows. No. If it's a Mac, do that. Else if Windows, app data. Else the .Ethereum. Cool. Home directory. OS to get home. So in the home directory, it's a data directory of .Ethereum. Cool. Default data directory. Default HTTP host. Host interface for the HTTP remote procedure call server. For the WebSocket. Cool. Vim doc. Ooh, this is decent size. So, sets up multi-protocol Ethereum nodes. In the model exposed by this package, a node is a collection of services. Yeah, okay. Which use shared resources to provide remote procedure call APIs. Services can also offer dev P2P protocols which are wired up to the dev P2P network when the instance is started. Resources managed by node. All file systems managed by a node are located in the data directory. The location of each resource can be overridden through additional configuration. Blah. Optional. If not set to location is otherwise specified. To access the P2P network, it starts p2p.server. Each host on the P2P network has a unique identifier, the node key. This node instance persists this key across restarts. Node also loads static and trusted node lists and ensure that the knowledge about other hosts is persisted. Run HTTP, WebSocket, IPC can be supported on the node. User can restrict endpoints. Can open database through service. Package node chooses a file system location in database. Database can be opened in memory instead. Yeah, resources are stored in directory with the same name as instance. So in your data directory, which is your .ethereum, cool, I don't think I need to drop that. Cool. Errors. So this is just going to be a list of data directory already used by another process, node not started, node already running, file lock errors. So here they're defining some interfaces. No, there's structure there too. Service context is a collection of service independent options inherited from the protocol stack. Pass to all constructions to be optionally used. So it's got this config file, but not this config, that's Geth config. An account manager. Accounts.manager. So is there a directory for accounts? Yeah, there is. Just the account manager, so that keeps track of all your private keys and stuff. Service opens an existing database. If the data directory is blank, return new memory database. If not, open a level DB. So this resolve path, I think I want to dig into a little bit before I go too much. If it's absolute, I think we looked at this yesterday actually a bit. If it's an absolute path, return the path. If the data directory is blank, return blank. So this C is the node name, I believe. So So they give the nodes a name so you can run multiple of them on the same computer, and they save it in a different directory in there. So you got your data directory, which is .ethereum. They join instance directory, which is defined here, but it's the data directory, so it's .ethereum plus the name of the node plus whatever the path is. Cool. So you open the database. So this is going to be the node's information from within the node's data directory. So it just opens the database, that gives you the resolve, that passes it down one, wraps it. Retrieves are currently running service. So I think if you pass like a miner or something here, it's saying service miner, gets the value of it, element, goes through this services list and sets it, the value of running. Cool, so I don't know what this services list is. And it's a service object. See if there's a map of service objects. Service constructor returns a service given a context. Service is an individual protocol that can be registered into a node. So a service is a collection of protocols, APIs, and has a start and stop function. So I think when you make Geth service, when you start your Geth instance, you can say if it's a miner, if it's got remote procedure calls, if it's got all those options you can enable and disable when you start the node. And I think that's what it means. Like if you don't want it to be a miner, you disable that service. If you don't want it to be on the P2P network, you can disable that service as well, probably. Geth.service. No, that's completely different. Installing Geth, program Geth. So you got these command line items that they're calling, and saying I think these are it. So you got RPC, that's a service you can enable. And then you pass in all the information for the RPC. And this is the APIs you're exposing: admin, database, Ethereum, debug, which I think is these. Maybe the descriptors. So these are all the things you can call. So if you're running, this is like running a web server, and you can call functions from another computer by sending HTTP requests to the server. And some of the functions are only exposed if you tell it to. And I think this is actually enabling all of them. But it's enabling access to the database, admin, which is all like the accounts and stuff. Ethereum, I imagine, is connecting to the actual network. The miner, Whisper, your transaction pool. Yeah, haven't looked into that enough yet. Web3. Cool. So this service takes your list of those, and also takes the peer-to-peer protocols, which is going to be Ethereum and Whisper and stuff. And you can stop and start it. And the service constructor takes the service context and returns a service or an error. Cool. So I have a service test file, and in it they go through and spin up some services, hopefully. Tests that the database correctly persisted. Creates a service context for config, which just has a name, a data directory, it being dir. Open database persistent. So they open the database in there. If that fails, they close it. Yep. Oh, they check that it exists after they make it. Ephemeral. So what's that doing there where it's saying ephemeral and stuff? So open database. It's been passed a string name. If it's got nothing to do with it, they're just naming it. But in their config, their data dir is blank, so it should be ephemeral. And make a memory one. Test context services stack. Test node config. Define a verifier that ensures that no operation A before it and no operation B after. No op service, where is that defined? No op service B. And they set up the service. And I think that just adds it to it. They start it. retrieve the currently running service registered. If okay, element.set value of running. Register stack.register. Is that in there? No. It's going to be in this file over here, the register stuff. So you're registering your services. Cool. Node test, node example. So, into the actual node file now. So you've got services. That the node is running. They've got a service context, which I can't see in here. But in here there's a list of services, a list of functions that create the service constructors. What's that in here? The service constructor, is that what it's called? Service context, no it wasn't. So where's service constructor then? You have the list of services that are currently running by the node. You have the peer-to-peer server and its config file. You got the lock. You got a config. You got an account manager. You got your list of APIs. Defining the endpoints, defining more endpoints, defining more endpoints. Cool. So new creates a new peer-to-peer node. And that is what we were looking at before. What else is here though, quickly before we dive into it? That's 50 lines itself. We got register. Injects a new service into the stack. Start. Creates a live peer-to-peer node and starts running it. Open data directory. File path, join the data directory, the node. So it goes into the data directory for the node. So they're joining it again. If it doesn't exist, return error. Locked instance directory. Flock, file lock. return nil. So all it does is it makes the data directory if it doesn't exist and locks it. Instance directory lock. That is flock function really is at the moment, but it looks like it's a file lock or folder lock. Start RPC is a helper method to start all the various endpoints during node startup. So it looks like start all the various RPC endpoint during node startup. It's not meant to be called at any time afterwards, as it makes certain assumptions about the state of the node. Start in process. Stop in process. Start IPC. Stop IPC. Start HTTP. Stop HTTP. Go. Start web service. Stop web service. Stops the node, which is quite a lot. Wait. Blocks the thread. So that looks like what they did here too. So they make the full node, which calls Node.new. They call start node, which is just calling this start node, which I imagine that calls this node.start. And then they call Node.wait, which is blocks the thread. Restarts attach. Creates an RPC client attached to the in-process handler. So RPC is its own package in this Go-Ethereum. So I'll have to look into that later and see exactly what it's doing. But RPC just allows, it's running a server essentially that you can talk to, and it allows you to call functions on it. So you're adding the client you lock it if the end.server equals nil. Dial in proc and in proc handler. Issues. So RPC handler, request handler. This returns the server. Service returns a service, so it does what the other one does as well. Goes through that service list because it's got this interface. So there's many different services that implement this, I guess. I'd like to see where they are. But data directory is just a wrapper. Instance directory, also a wrapper. Account manager. HTTP endpoint. service endpoint. Open database opens an existing database with a given name. So this database I don't think is a chain database, because that's external. And this is, if you've got a node, it's going to have its own database. Resolve path returns the absolute path of a resource. So that's just wrapping this resolve path from the config. So it puts .ethereum .node name / whatever's in there. APIs. Cool. So this is where we can actually see what services are there. So this RPC API admin debug web3. New private admin API, new public admin API, debug handler, public debug. Admin debug web3 adds this service under this namespace. So when this mate here was saying he wants admin, that'll probably give him those two because they'll be included in that namespace. So these are RPC API namespaces. There's debug and there's web3. Cool. So it looks like this is actually doing everything. When it starts up, when this starts up, a big part of it is listening and being able to submit over several things like RPC, also through HTTP and all that stuff. So this is what's setting up all those listeners. And if we go to the top, /new node, node.new passes a config. Makes a copy of the config. Copy config and resolve the data directory so future changes to the current working directory don't affect the node. So what's abs data do? Okay, yep. So they just get the data directory is just saved as like .ethereum or something in it originally. They get the actual address that's on the machine and save it, so it just can't be changed later on. Ensure that the instance name doesn't cause weird conflicts with other files. Yeah, it must not have slashes in it. You got a key store. Can't have .ipc in the names. Okay, so it's just stopping you from having stupid names in your instance. They make this account manager here, which we'll have to look into later. They make a logger, and they return a node. And the node is just a structure that's got a key store, the config file, no functions at the moment, no service functions, no endpoints. No, these are going to be defined in the conf.endpoints. And a logger. That looks blank at this point. So they make a Node.new, bunch of blanks at this point. And they call start node. It goes to utils start node. Wallet events. So where do they pass in the actual services, do we reckon? So what's in this utils file then? Set eth config. This goes through the context. Check exclusive, developer flag, key store, set etherbase, set transaction pool, set eth hash. So this is setting more stuff in the command line. It says going through the config file. If this flag is set, cache flag name or cache flag name, the config tree cache is set to it. Borrowing, going through flags, minor if the flag, this is just if the minor flag is set, the minor floor is it, blah. And force enable this in dev mode. So that just sets a heap of the configuration files, flags, from the flags. If is set, config estats. Set, the same thing. So this is setting the config stuff. this makes a config node. So why do they need stack in there? Oh, they get the account manager. That's it. Cool. So they create here a blank config here. Geth config. And they set the node config, make a new, so this gives it some same defaults. Make a new node, which has got nothing in it at the moment, it's blank as well. They go through heaps of config files, and that's probably it. There's just so many flags at the start. And that's all that does. So, node, make full node, then they call start node, which is going to be this utils start node. Which is not there. Bugger. cd command, cd geth, no, cd utils. What's it called? Start node. Function start node. What? Upper directory, utils command 66. And it literally just calls stack.start. Cool, so back into here, register, I haven't seen it called register. Starts, creates a live peer-to-peer node. So we initialize the peer-to-peer server. N.server config from the peer-to-peer settings in config. Get the private key, get the name, get a logger. So they build this server config file. And then they make the peer-to-peer server with the config. And it says starting peer-to-peer node. No. Geth. Hello file. Vim hello. Didn't do anything. IPC endpoint. Service functions I thought was blank at this point. Create a new context for the particular service. Services make service. So that's empty at the moment. For in the range. So I thought that's blank. Your account manager got a benchmarks, so it's built in that at this point. For kind in range services. I thought that was blank too. So this is assuming there's stuff in there. So in this new, so I'm getting the feeling now that when they go through this config here and they set dashboard, set ETH config, they might put stuff in there. So in utils, flags, register ETH service. So that does actually look right. So if I go one 156. Make full node, register ETH service. So that's what that's called. Let's just make full node. Is that one? So earlier, this makes the config stuff. Make config node. Then we register the Ethereum service here. make full node make full node, which calls the make the config, then it registers the Ethereum service. Does some other crap, and then it starts it. So the register Ethereum service is here. Which is in utils. Upper directory, utils, flags. Sync mode, if it equals light. Stack.register. And then making this service context. No, they're making this constructor here. Full node equals eth.new. Cool. So up here, they've got upper directory, eth. There'll be an eth in here, I hope. Nope. CD eth. New. Nah. No, it's not there either. Okay, cool. So stack.register takes this constructor to the service constructor. And it appends it to the service functions. So we've got in this start, it goes through, it's got the eth service in there, so it's got one. Makes the config for the kind in range services. They call the constructor. So they get it out of there. And they call it constructor save the service. Kind equals get the type. If exists, services kind equals service. Cool. So that's what they call it. And add it to the services. Now they call the structure which returns a service. Then they go through the services. Running.protocols. So the service has a list of protocols in it, and they append that to the running ones. running.start. P2P server. So they call the P2P server, this is what the running is. And they start the P2P server. They set in the protocols for it here. Start each of the services. So what protocols are in it? I do not know. That's going to be defined in the ETH1. The ETH package. So the ETH package is going to give it a bunch of protocols. They add that to the P2P server. They start running the P2P server. Then they go through the services. Still don't know what sure they are. For client services and range services. Service.start. If it's already started, stop. Mark the service started for a potential cleanup. Start the remote procedure call interfaces. Ooh, cool. So these are really wrapping. They got this service constructor, which is being given to it by, if it's an ETH service, it's got a heap. So this is the ETH protocol file, and it's got a heap of protocol messages. This actually is quite small. Let's quickly do this. Protocol messages. Error messages. Transaction pool, status data, interface, structure. Hash or number. Encode RLP. No. Block body. Vim API. So yeah, when this ETH, let's start the new ETH, whatever, it's going to return a list of protocols and services that the node should be running. And at this point it doesn't actually do anything because it's whatever this passes back to it. So it's handballing it to another area, and obviously that area is going to be something that needs digging into. Private admin API. And this is what that other thing was calling before, wasn't it? Import chain. Dump block. So what was it calling actually? Service context. Ethereum.new. Which is a bit scary, because buried in here somewhere, is the new function. Which I don't know where. Anyway, I think we'll look at that later. All we know now, which actually wasn't very interesting, which kind of makes sense, is the node set up and running really just collects, it sets up all the config stuff, and then it collects a list of protocols depending on the flags that it's going to run. Sorry, yeah, so like the Ethereum service, which is what's talking about here. And then it adds them to these arrays, which are just lists of things it's going to run, and then it says run, and it iterates through them and runs them. And it still like handballs that down to the next level. It's a bit disappointing because there wasn't anything really meaty in there. Yeah, but I guess I now want to go back and look at, in the P2P, this server file a bit more in detail. Because we went through protocol RPX pretty deep in message in here, which is all nice and good. But now the server's running, not the server, the node is running a P2P server, which is this. And that, if I can remember correctly, is quite a big file. Yeah. So I'll try go through that tomorrow and dig into it a bit more and figure out when it's running the server. And we've got some, we know it's some information. That's been passed to it already. Lock, unlock, running true dial, new transfer, dialer. Set up local node, set up listening. Yeah, it's doing quite a lot. So that we kind of want to go in a little bit in depth. And then we want to look at the RPC server, which is also running. Cool, but we'll leave that for tomorrow. Thanks for tuning in. Take care.